Hey everyone, welcome to Hawks Tutoring. I hope you're having a great day. Today we are doing a part tutorial video, part topic video. That's because I want to use this question from the textbook. So that is question 10, multiple choice in chapter 4, to explain a concept to you in complex numbers. So hopefully this video helps you further your understanding of complex numbers, and hopefully it is helpful for you in general, okay? So let's get into the video. Question 10. The zeros of the polynomial 2x squared plus 6x plus 7 are alpha and beta. So that's your answer. So if the zeros just mean if you were to let this expression over here equals to 0 and solve for x, your answer would be alpha and beta. The value of mod of alpha minus beta is equals to what? Right. So, okay, let's set up the equation first. So 2x squared plus 6x plus 7 equals to 0, okay? Right, so I want to show you the two ways of solving this. So one, I would call it using the quadratic formula, and the other way, I call it using complete the square. So there are two ways, either use the quadratic formula or complete the square. And let's get into the first one, quadratic formula. So if you want to use quadratic formula, it's very simple. The formula, as you learned in method, should be negative b plus minus square root b squared minus 4ac over 2a. And then all you have to do is sub the numbers in. So in this case, negative b is negative 6 plus minus square root. B squared will be 6 squared, so that's 36, minus 4ac. 4 times 2 is 8. 8 times 7 is 56, so that is negative 56. And then everything over 2a, 2 times 2 would be 4, okay? And then afterwards, just keep simplifying this as much as you can. That is plus minus root of negative 20 over 4. You can further simplify that down. So root of 20, you can take 2 out and you'll be left with a 5. Because if you were to bring 2 back in, that's 4. 4 times 5 is indeed 20. Negative 5 though, I forgot about that. Over 4, right? And then what you can do here is keep simplifying. That's negative 3 plus minus root 5. And before I forget, you do have an I here as well, because negative 5, you can write it as root 5 times root negative 1. Root negative 1, as we all know, is I, okay? Equals to 2. So that's what x is. X is either negative 3 plus root 5i over 2 or negative 3 minus root 5i over 2. And of course, as we know, there are two answers, A or alpha and beta. So it doesn't matter which one you pick, the negative being alpha, the positive being beta, it doesn't matter, because at the end of the day, it's going to be under the mod, okay? So let's do alpha minus beta under the mod. So let's assume alpha is the positive one. So I'll just make a shortcut here. Alpha positive, beta equals negative. Do not write this though, right? Alpha, let alpha equals x equals to negative 3 plus that. But since this is multiple choice, it doesn't matter. Just do it quick, really, especially in the exam. Time is of the essence. Right, so x, or not x, whoops. So that would be alpha minus beta and the mod. That is mod negative 3 plus root 5i over 2 minus negative 3 minus root 5i, and then everything over 2 as well. And then you have the mod, okay. And then negative 3, so everything will be over 2, that's fine. Negative 3 minus minus 3, that would be negative 3 plus 3, so it actually cancels out, so that's quite nice. And then what you have here is root 5i minus minus root 5i, so that is root 5, so that's 2 root 5 with the I. And then what you end up with is root 5i under the mod. Excuse me, this really in complex number, the mod is your magnitude as well. So what happens is you square root and you square root the 5 squared plus, well, our real coefficient is 0. So what you end up with is root 5, okay? And if you check all your answers right here, it is root 5. So that is A, right? So answer is A. There we go. Okay, so that is solving this multiple choice by hand. You can also use calculator, obviously, for multiple choice, but I'm just showing you guys, this is a topic video. I'm just showing you guys the two different ways, just in case this is in Tech 3. Right, so that was quadratic formula way. Now we'll do the complete the square way. So if you want to complete the square, so we have this equation right here. You have to always make sure the coefficient in front of x squared or z squared is always 1. In this case it is 2, so you need to factorize that out. So we're just essentially taking 2 out, so 2x squared plus 3x. And even though this is 7, you're like, I mean, usually if it's a 7 or an odd number, I can't really take 2 out, right? But if you're completing the square, it does not matter. Okay, you can still take 2 out. There's no rule that says you can't take anything out. You can't factorize 2 out, okay? You can even factorize 4 out if you want, but of course that doesn't solve this question, okay? So we will take 2 out and we will have this as our equation because we're going to divide both sides by 2 and it's gone, right? Then afterwards, if you want to complete the square, you look at the number in the middle, so that's 3x, or the second term really, and then you halve that, so that's 3 on 2, and then you square it, and then of course 3 on 2 squared never existed. It was never in this equation right here, so you have to subtract it back, and then plus 7 on 2, that was what we have. Of course, this first 3 terms right here is your perfect square. You can summarize that under x plus 3 on 2, fully squared, and then we are going to simplify this, so just add them together. That is negative 9 on 4 plus 7 on 2, which is 14 on 4. I'll just make it easy for you to understand. X plus 3 on 2 square, minus 9 on 4 plus 14 on 4, that is plus 5 on 4. Now this is important whenever you complete a squared complex number. Now in methods, you wouldn't be able to do this. That positive 5 on 4, you shift it to the other side, you get negative. And of course, when you square root that, you can't do it. But in Special, you actually can. And with this, what the textbook recommend you do is you turn this into a negative, okay? So instead of having the positive sign, you can have it as a negative sign, but instead of writing 5 on 4, you can write 5 on 4 I squared, okay? Alright, so what's so special about doing this? So the reason why we did this is because you can get this format. This is a squared right here, x plus 3 on 2 is a, and then you square that, minus b squared. So 5 on 4 I squared, that is b squared, equals to 0. What that does is you can write a minus b, a plus b equals to 0, and then essentially solve for x. So let's apply that over here. So this is the magic essentially for complete the square. And make sure you do know this method because it could come in handy sometimes as well, okay? So x plus 3 on 2, that's fine, that's our a right here, so we're doing this right now. Minus b, now just be careful when you minus b, this negative sign, just ignore it. B is just this one right here, but you have to square root that, okay? So square root 5 on 2i, right? And then the other side is x plus 3 on 2. Do not change the sign. This is a. A is always x plus 3 on 2. It's not x minus 3 on 2. It's always x plus 3 on 2. But you change the sign here instead. See, that's a plus b now. So that's plus root 5 on 2i equals to 0. Okay? And of course, if you want to solve for x, that is x equals to negative 3 on 2 plus minus root 5 on 2i. And essentially what you get is the same thing as what you have over here. X equals to negative 3 plus minus root 5 on 2i, and you can proceed to go through the same process afterwards. So let alpha equals a positive, let beta equals a negative 1, and then just find the mod, the magnitude of that, okay? And your answer should still be A. So obviously the complete the square is a little bit longer, but of course it's good to always know both of them, right? So that pretty much completes this topic video, guys. Just wanted to share to you guys the 2 different processes just in case you might need it. Aside from that, guys, thanks for watching and I'll see you in the next video.